That's still -1 though.
Yes.
Oh, but it's absolute value.
But it's an absolute value.
Yeah.
Okay, so here it is, just set up and inverted and multiplied.
But it's a 1.
And now,
The final answer is 1.
yes, it is.
Failed.
It is. The final answer ends up being 1. So we've got, if I put together these pieces to help my eyes out, and then this piece is really an n plus 1 over an n, and then this piece is an n plus 1 over an n plus 2. So we'll look at each of these little pieces and use our old exponent properties. -1 to the n plus 1 over -1 to the n, you keep the base, which is -1, you subtract the exponents, n plus 1 minus n is just a 1. That inside that radical, you've got really an n over an n plus a 1 over an n. But an n over an n is just a 1, and a 1 over n, as n goes to infinity, is just a 0. So that piece made a total of 1. The back piece, the top's going to infinity, the bottom's going to infinity, the derivative of the top is 1, the derivative of the bottom is 1, so I got a 1 out of that piece also. Since this is an absolute value, the absolute value of -1 is 1, and the test failed. Yeah, this is usually where I write tough bananas. So now you don't know, and you're still trying to find the answer. So now we go to it and we say, okay, what should I try?
Alternating. Must be the alternating series.
Oh, no, it's not the root test.
Alternating series.
Yeah, I would have tried the alternating series test because it's an alternating series. So if I do that, alternating series test, I need the limit as n approaches infinity of square root of n over n plus 1. No, that's just a limit. In the alternating series test, we have two things. We need to check about the non-increasing nature of the terms, and we need the limit of the nth term to... you could, or you can do L'Hopital's rule, whichever you prefer. I think I'm going to go with L'Hopital's rule. So if I do a little L'Hopital's on this, this is really n to the
1/2.
N to the 1/2, and the derivative of n to the 1/2. 1/2 n to the negative 1/2, and the bottom derivative is just a 1. So this is really 1 over 2 times the square root of n, and as n goes to infinity, it's just a 0. That's good. That's good news in the alternating series test. Bad news in the...
If the limit goes to 0, it converges.
Nth term test for divergence. In the nth term test for divergence, we would be depressed again because now we would have done 2 tests that failed. But it's okay. This is the alternating series test. So now I need to show that a sub n plus 1 is less than or equal to a sub n.
Always prove that.
And I will just write you a note. Use first derivative and show that it's less than 0. You can try that on your own. I did it other ways, and it's big and nasty other ways. It's not too bad with the derivative. Okay, but now you do need to see the root test. Go to this page in the book,